here's part 2 of chapter 11 notes, which we will look at practice B on simple pendulums and practice C, which is on mass spring systems. To start off though, here are your answers to practice problem A notes. These are also posted on your links for your filled in notes. Okay, first slide then. Here is just an overview of simple harmonic motion of a pendulum and then of a mass spring system. Please make sure that you look over this page, especially this column right here. This has a ton of good information that you probably already have seen pre-test and will be seeing throughout the chapter in labs, notes, and inevitably the post-test. So make note of this page, please, guys. Okay, so 11.2, we're going to talk about measuring simple harmonic motion. Some definitions here. The first one is amplitude. The amplitude is maximum displacement from equilibrium. Maximum displacement from equilibrium. You could be a little bit more specific and say from equilibrium position. Okay, so right here's our amplitude. Here's our equilibrium line. So we're looking at this height right here. Okay, this is what's going to be your amplitude of the system. Now for a pendulum, it's going to be more specific. For a pendulum, it's going to be the angle that you're dealing with. So angle between equilibrium and maximum displacement. For a mass spring system, it's going to be different yet again. This is maximum amount. I'm just going to abbreviate that. And then loosely use the word spring is stretched or compressed. From equilibrium position. The units that you're going to use for all of them, 1, 2, and 3, are going to be meters. Period is defined as time it takes for a complete, cycle to occur. In other words, you're looking at from starting point back to same starting point. So once again, picture yourself swinging on that swing. So you started on the left-hand side of the swing, you swung past where the bars are, you swung to the right-hand side, and then back and forth, okay? So back and forth, back and forth, back and forth. Every time you go back to the spot where you started from, that's a complete of one period, one cycle. The units that we're going to use for that are seconds. Something else that you guys need to put in here is that the variable is a capital T. Okay, period is a capital T. Amplitude is a capital A. Okay, frequency. Frequency is defined as number of cycles and I'm going to be really specific here and put pendulum in parentheses, or vibrations, and I'm going to put spring in parentheses there, per unit of time. Okay, so the variable should make sense, or sorry, the unit should make sense. Number of cycles per unit of time, so it's going to be 1 over S. What we call a 1 over S, a hertz. Okay, that's what a hertz stands for. 1 over S is a hertz. Frequency's variable is a lowercase f. Okay, frequency is lowercase f. Something to note is that period and frequency both measure time. So the equations that you're going to look at are either period equals 1 over f, or rearrange this, guys, so that it says f equals. If you rearrange that so it said f equals, then it would be 1 over t. So these are two equations that you need to be comfortable with throughout this unit. Period of a simple pendulum. Two things that it's going to depend on are length and free fall acceleration. The equation that you're going to use is period equals 2 pi times the square root of L over G. You may see it written as A sub G. So if you see A sub G, that still means G, which still means 9.81 meters per second squared. Okay, obviously your period is measured in seconds, your length is measured in meters, your acceleration due to gravity is a constant, but that is meters per second squared. Okay, please use the pi button and not 3.14 whenever you're solving these problems through, guys. Okay, period of a mass spring system. Period for a mass spring system is going to depend on mass and spring constant. This should make sense that that's what you're looking at throughout these, the mass and the spring constant. So the equation that you're going to look at here is period equals 2 pi square root. Everything is the same there. And then inside your square root, it's the two variables that the period for that particular system are dependent upon, mass and spring constant. So your period is measured in seconds. Use your pi button. Mass is in kilograms. Your spring constant is in newtons per meter, which it is a constant once again. Your K is a constant, so you're not going to count it when it comes to sig figs. Let's look at sample problem B here. Reading through sample problem B, you see that it has a period of 12 seconds. So you know you want G right off the bat on that, because it's talking about a simple pendulum, and simple pendulum is dependent upon length and free fall acceleration. Length happens to be what your unknown is. Your original equation is period equals 2 pi square root of L over G. You're trying to figure out what L is, so you want to square both sides. So T squared divided by 4 pi squared, 2 squared is 4, pi squared is pi squared, equals L over G. So what this really is going to give you is T squared times G divided by 4 pi squared equals L. Let's plug in, guys. You get 12 squared times 9.81 divided by 4 pi squared equals, put that in your calculator, you should see 36. You really only want two sig figs, so 3.6 times 10 to the first meters is your length. So once again, if you're talking about a pendulum, okay, if you're talking about a pendulum, then you need to have free fall acceleration and length taken into consideration. Here are your answers to your practice B problems. Those will also be posted on my teacher page with the filled in notes. Sample problem C, you are looking at a car, has 4 springs on it. So the first mass that you come across is 1275 kilograms, and the second one is 153 kilograms, thus giving you a total mass, a total mass that you want to divide by 4 to give you 357 kilograms per spring. The period in which these springs are oscillating is 0.840 seconds. So what is the spring constant of each of these springs? That's why we had to take that total and divide by 4 so that we could figure out what the mass of one spring was. Well, since we're talking about mass spring system, that's going to be 2 pi square root of m over k. Square both sides, rearrange everything. This is going to give you k equals 4 pi squared times m divided by t squared. Let's plug in 4 pi squared times 357 divided by 0.840 squared. Plug that into your calculator, please. 4 pi squared times 357 equals, divided by 0.840 squared equals. That should give you roughly 2.00 times 10 to the 4th, You want 3 sig figs for your final answer, so your K value is 2.00 times 10 to the 4th newtons per meter. Okay, so now here is your correct answers to your C problems that you need to work on. And the next video we'll move into D.